Our eyes are more than just a feature. They allow us to see the world and enjoy it. They allow us to marvel at the different places around us. But oftentimes they can bamboozle people, and when they work together with the web, they make our minds go into a tailspin and we're left in awe. Don't take my word for it. See for yourself why these 10 amazing illusions will blow your minds. Number 10. Corn Sweet Illusion. Take a look at this photo. It's obviously one towel with two sides that appear to have a differing level of contrast. Which one is darker? Is it the one at the left or the one at the right? In order to get the correct answer, let's cover that thin line dividing them. Now you see that they're actually the same color. You have just experienced what is called the Corn Sweet Illusion. Discovered by Tom Cornsweet in the late 1960s, this optical illusion is characterized by two compared variables separated by a thin band of gradient. By glancing at it, it will look as if one has a heavier contrast than the other. But in actuality, they have the same level of contrast. What causes this confusion in our visual perception? You can blame that thin division between the two hues. The brain is used to interpreting colors through the edges, and because the perceived end of one area suddenly differs from the edge of the other, we interpret it as if they have varying degrees of color. It is only when you cover that thin gradient that you realize that indeed they're the same. Number 9. Barber Pole Illusion. Back in the day, businesses didn't use words or branding names to label their industry. Instead, they used various signs outside their doorstep, and one of the most popular is the barber pole for barbershops, which we still see today, and it brings us one of the simplest yet wonderful illusions. Take a look at this video and direct your attention to the pole to your left. When it starts moving, it appears that the colored lines are moving upward. It's like magic, because new diagonal lines rise from below the cylinder. Now look at the L-shaped image to your right. In contrary to what you thought that it was moving upwards, it is actually going sideways. How does this happen? Consider this an issue on aperture, because we are focusing on the lines. It gives the illusion that it is obliquely moving upward. Now, try sticking a pin at one part, and you'll realize that truly all it is doing is just moving horizon. Besides, if it was moving up, shouldn't it be off the ground already? Number 8. Impossible Trident. Here's an incredibly annoying illusion that will have you scratching your heads out of amazement and confusion at the same time. How many prongs are there in this illustration? Is there just 1, 2, 3, or maybe there's none? No matter what you do, such as covering the ends of the supposed prongs of this drawing, you will just end up getting confused even more. This has been the root of a lot of perplexed arguments, that's for sure. This illusion is what you call the impossible trident. So what's the deal with this? The thing is, it is really impossible to make out a trident out of this picture. This is because despite it being a two-dimensional illustration, your brain will try to make a three-dimensional model out of it. It's just the way it is. Even if the image your retina sees is flat, your brain assumes the depth of the picture, and therein lies the confusion. It's like your brain and your eyes are quarreling over what is really in front of you. Number 7. Orbison and Illusion. Not all optical illusions already have definite explanations behind them, and that makes studying these even more interesting. One of the examples of which is the Orbison and Illusion, which brings a lot of theories as to how it fools our brains. In front of you is a diamond which is placed on top of radial lines that goes from left to right. Try staring at it for a few seconds and you might observe something weird happening. It's like a part of the diamond is bulging. Don't worry, you're not going bonkers or anything. Rather, that's the illusion. And believe it or not, people are still debating how it works. One of the theories concerning this illusion is that the patterns behind the shape cause the distorted perception. Others think that the degree of angles might have a hand in fooling our brains. Another suggests that there's a misperception between our neurons and the visual system. So again, it's an internal battle of what really is in front of us. Number 6. Ebbinghaus Illusion. Let's play a little game. In front of you are two circles, which are surrounded by other circles. The one at your left is surrounded by smaller circles, while the one at your right is surrounded by bigger circles. The question is, which of the two center circles is bigger? The one at the left or the one at the right? Chances are you'll say it's the one at the left, but you are wrong. The correct answer is neither. Both the center circles in the left and the right are equal in size. Don't believe me? Try covering the surrounding circles for both the two groups. This will reveal that indeed they are identical. This is the Ebbinghaus illusion. How did this happen? Our vision operates on the concept of context. It takes into account the surrounding objects to judge the subject of perception. This is what creates the illusion. It's also why we are sometimes confused if an item is small or simply far away. Number 5. Poggendorff Illusion. Here's another optical illusion, which you might be seeing more often than you expected. Check this illustration right here. There is a diagonal line that passes through obscuring upright parallel lines. At first glance, it appears that this results in a misalignment of the diagonal line, causing it to appear as if it is broken. Or is it? This is a Poggendorff illusion, named after the physicist and scholar J.C. Poggendorff, after he discovered it in 1860. While it looks like the diagonal line isn't aligned anymore, it is in fact still one straight line. What causes it to appear broken is because of the direction of the obstructive parallel lines, which forces us to think that one is a bit higher or lower than what is required to join them together. Interestingly, you can also see this illusion on the flag of the United Kingdom. Two diagonal lines crisscross and meet in the center where they're obstructed by the white lines and appear as if they're broken. Then again, they aren't. Number 4. Ambiguous Cylinder. If you think the previous illusions look very confusing, then you haven't seen the Ambiguous Cylinder illusion yet. It is so baffling that it might drive you mad trying to figure it out, to the point you might think it isn't natural. But believe me when I say it isn't magic, but is heavily reliant on science. This clever illusion was created by major university's engineering professor, Dr. Shuhara Kukicha. Circle shapes were placed in front of a mirror, but then puzzlingly reflect squares. Turn it around, and then the shapes exchange places. And it was no trick. Rather, it was all real. How did this happen? The clue lies within the materials themselves. The thing is, they're neither circular nor rectangular, but a hybrid of both. The edges are made soft, so that's how it's a mix of both. The next procedure that will distort the image is through the perception. Depending on the angle, the actual object may look like a circle while the one in the mirror looks like a square. Take care of the lighting and voila, instant magic. Ambiguous, right? Number 3. Bezold Effect. If you love mixing and matching your clothes to match your skin tone or look brighter, or perhaps you are experimenting on certain color combinations as you renovate your house, then you might be unconsciously seeing the Bezold Effect already. To give you a better visualization, look at these streaks of red. One part has a white background while the other half has black behind it. Now look at it intently and try to spot the difference. The one at the left appears lighter, while the other one on the right looks darker. But the thing is, it's just the same hue. How did this happen? Again, you can blame how your brain takes into account the surrounding elements, and that influences how we see things. The background hue influences your perception, and the thing is you aren't even changing the base color. Willem von Bezold discovered this illusion by accident. He was trying to decide on a color for his rug, so he experimented with the colors, and that's how he first noticed it. Neat, right? Number 2. Necker Cube Illusion. Let's play another mind-boggling game. Take a look at this box, and then focus your attention on the red dot. Stare at it for a few seconds. Now tell me, is the red dot at the far end, or is it at the near corner of the box? This is the Necker Cube Illusion. Probably at first sight, you were thinking that the red dot is at the far end or probably at the near corner. Then as you stare at it closely, it suddenly flips position, and you can't decide what the orientation really is. For some, it might go back and forth, confusing you even further. So what is really happening? Similar to the impossible Trident illusion, we see a two-dimensional figure, and then our brain tries to create a three-dimensional image. The problem is that the illustration does not give you enough detail, or that it gives you confusing hints, causing it to scramble in your head. It then becomes a different perception from one person to another, because our unique brains will try to interpret it differently. Number 1. Hybrid image. Last, but definitely not the least, here's an optical illusion that will make you want to gouge your eyes out. It involves taking two very different pictures together and fusing them, and you can only see one of the two depending on your distance. For this example, we'll fuse Albert Einstein and Marilyn Monroe's photos. They look nothing like each other, but the angle and shading makes it a great illusion that will amaze you. If you are near the photo, you see Einstein, and then as you go farther, you see Monroe. In some cases, all you need to do is squint, and then you will be able to see Marilyn. How does this work? It had something to do with the illustration itself. Einstein's features are drawn with fine, dark black lines, which is why you see them up close. Monroe, on the other hand, takes the blurry side, so when you go farther, you won't be able to see the fine lines and instead see Marilyn.